Question number 13, another pick from experimental physics. So you see what I have been saying, that one needs to pay specific attention to this thing. All right, an ideal battery of 4 volt and resistance R are connected in series in the primary circuit of a potentiometer of length 1 meter. So here is a potentiometer of length 1 meter, and the resistance of this potentiometer is 5 ohm. Now it says that there is an ideal battery of EMF 4 volt and there is a resistance R which has been connected in series there. The condition requires we need to calculate the value of R, and for the given condition that to give a potential difference of 5 millivolt across 10 centimeter. So here in 10 centimeter length you require a potential difference of 5 millivolt. I think with that given information we can calculate the value of current. 5 millivolt, so that's 5 into 10 raised to the power minus 3 and divided by resistance of 10 centimeter. So that's going to be 1/10 and that will be 0.5, which is 5 into 10 raised to the power minus 1. So here you go, that the value of current comes out to be 10 raised to the power minus 2 ampere. Now I think this is so simple. Once you get the value of current, the current will be equals to, that can be so easily written that the expression of current can be written as 4 divided by R plus 5, because these two resistors are in series. So you do that simple calculation, and when you solve it, you'll get the value of resistance as 395 ohm. So option number 4 comes out to be the correct option for question number 13. Let's see the next question now. Question number 14, vector from the topic heat transfer, and more specifically heat transfer by conduction that has been asked. Let's see what it says. A cylinder of radius R is surrounded by a cylindrical shell of inner radius R and outer radius 2R. The thermal conductivity of the inner is K1 and that of outer is K2, and we need to calculate the effective thermal conductivity for heat flowing along the length of the cylinder. So it's something like this. Let me show the situation with the help of a figure. So here I get this as a solid cylinder of radius R. So let's say that's a solid cylinder, and around the solid cylinder there is a cylindrical shell of inner radius R and outer radius 2R. So that's not difficult to imagine now. So here is the situation. This is another cylinder, but a cylindrical shell of inner radius R and outer radius 2R. So that's the situation. And now we need to concentrate on the flow along this. So if you talk about flow along this, that means the resistances are in parallel. So before that, let's try to calculate what are the value of resistances. If I call R1 as the inner one, that's L upon K1 into area A1. Well, A1 is pi R squared, that's not a big deal. And R2 is L upon K2 multiplied by A, or A2, and A2 is 3 pi R square, the area, the cross section of the outer cylinder. And these two are in parallel. So when the resistances are in parallel, so the net resistance would be R1 R2 by R1 plus R2, and this can be equated with L upon K effective into A1 plus A2. Because when you talk about K effective, you assume that the entire thing is homogeneously made of a single medium. So length is L and K effective and the area would be A1 plus A2. a simple calculation. It doesn't require very tough calculation. And when you solve this, you would get option number 2 as the correct option for question number 14. Now it's time to move to question number 15. Question number 15 that has been brought from the topic of relative motion. And now let's see. It says there is a passenger train of this length and is moving with this speed, and there is another freight train of length this and speed this. So let me call the passenger train by the subscript 1 and freight train by subscript 2. You need to calculate the ratio of times taken by the passenger train to completely cross the freight train when they are moving in the same direction and in the opposite direction. So it's a very preliminary concept of relative motion in a straight line. So let's see, when they are moving in the straight line, the distance that has to be covered for complete passing would be L1 plus L2 and same direction. So the relative speed is going to be this. And traveling in opposite directions, still the relative distance that has to be covered to completely pass through, the distance is still L1 plus L2, and the speed this time would be V1 plus V2. So all I need to do is that I need to find the ratio of these things. You calculate it, you would get option number 3 as the correct option. That's a very simple calculation, so I don't want to stress much. Fine, now let's move to the next question.